Hi, I'm Ernie. I'm going to show you how to take a 3D printed plastic part and cast it out of metal. What we have here are some examples of what I've done in the past. These are aluminum. Uh, this is aluminum that's been sent through a tumbler and a few other things. This one back here is copper, and it came out pretty oxidized. So it's been through a tumbler and a few other things to clean it up. And then this last one over here is Nordic Gold, and that's an alloy of copper that it's mostly copper and aluminum and a few other things. And it came out that shiny. I have not polished that at all, and it came out really nice. And look at all the detail. That's great. Now, these aluminum ones over here also came out that shiny. No polishing or anything like that, so that's great. This one here is the last thing I did. It's a cube in a cube. It actually had 5 cubes nested together instead of 2, but the inner ones were too thin and fragile and they broke. So we're going to redo this one today, and with thicker sides, and there's going to be 4 nested cubes. So stand by, it's going to be fun.
Hi, I'm back. I just showed you the castings I've done before. One thing to note on those is on the miniatures, the little figurines, those are usually done with a sculpt program and a sculpting program, or those there just happen to be downloaded from Thingiverse, and that's an easy way to do it. But if you want to make your own original designs, you can use a sculpting program. A lot of people use something like Blender. Fusion 360 also has some sculpting capabilities, but I don't use either one of those very much because I'm not that artistic of a type of person. I'm more of an engineering type, dimensional geometric things instead of the organic shapes. So I use Fusion 360. Or any other CAD program will do as well. So let me get the thing pulled up here. Okay, so here's the cubes, and this is what we're going to try to 3D print and cast. One thing I like about Fusion 360 is, like I've already got this done, so instead of just working my way through it and doing it with you watching, where I could make mistakes or whatever, I can just slide this timeline back and show you the steps I went through. So first thing is to draw a cube. You could do that by doing a sketch first and extruding that sketch into a cube. But I chose to use what I call primitives. Down here in this area, you can select box, and then by clicking and dragging, you can create a cube out of that box. So that's what I did. Let's move forward on the timeline. There it is. One thing to watch out for, the vertex this box is setting right on the origin, which will not be lined up with the next step, but we'll fix that. I'll show you how. Next step is to first, forgot something. Show you how big this is. Measure, inspect, measure. Let's measure this edge. That edge is 1 inch long, so you can tell what size of cube we're working on. 1 inch on the edge. Okay, next thing I did was some algebra, math, Pythagorean theorem, or whatever you want to call it, and determined what size of sphere I would want to cut out of the middle of this and still leave zero point 0.1 inches at the thinnest point on this biggest cube. 0.1 inches is my goal. So after a little bit of math, I went up here to primitive sphere and then click and drag and put my sphere up there. And there it is. Again, it's off center from the the cube. So we're going to move that cube over to the right place. Do that with the move tool, move copy. We're just going to move it, and boom, there it is. Now we want to use that sphere to cut out the middle of the cube. So you go up here to the combine. The target body is the cube. The tool body is the sphere. And then you go to cut and then hit OK. And again, we've already got it done, so I'll move forward on the timeline, and there's what it looks like. And again, this is 0.1 inches thick between where the sphere cut and the edge at its thinnest point. Okay, next step is we want to make a smaller version of this that'll fit inside of that. So after a little bit more math and all that, I decided to do that. I want to scale it to 65%. The scale function's up here, but there's not a scale copy. So first thing we have to do then is make a copy of it that we can scale down. So again, using the move copy command, I made a copy of that same size, moved it over 3 inches. Next, we use that scale command that I talked about, but there's thing you got to watch out for. If you just scale it now, it's going to scale about one of these points here, which then it's going to be off center and not lined up to make it easy to move back inside of there. So I wanted to put a construction point in the center of that sphere. And to do that, let's rotate this thing up. Go to construct. That's not what I want. Cancel. Go to construct, pull down point at center of sphere. You select that, and then you select that sphere, and it'll put a point point in there. There it is. So then you scale about that. So you go up to scale. Boom. The entity will be the cube. The point will be there. You want it uniform, and then you tell it how much you want it to scale by. And I put 0.65. And the result of that is, boom, right there. Next is leave a copy of it there, but move one back inside there. So using the move copy and selecting copy, we go. There it is. Put it in there. Repeat those steps a couple more times where you scale and then move copy, their scale, move copy, scale, move copy. Except that last one wasn't a copy. We actually went ahead and moved it in there. At this point in time, I went in here and I measured the thickness of that using the inspect tool. And that's getting pretty thin, which means it was going to be hard to remove the supports after printing, after casting. So I decided there's no reason to have that inside one hollow like that, except for looks. It looks cool, but I decided to go ahead and replace it with a solid cube. Make it a little sturdier. Increase our chances of a good print and a good cast. Okay, so that's basically the model we want, but so the next step is we got to export it as an STL file so we can use that in a slicer program getting ready to 3D print it. But I need to show you something. Go back a couple steps here. Okay, now the typical way in Fusion 360 to do an STL file is you select a body, right click, go down, save as mesh, and that'll get you an STL file for that cube. The problem is it's only for that cube, but what I want is an STL file for all 4 cubes at the same time and in the proper places so I can import those as one model in the slicer program and not struggle with placement and all that stuff. So that's the easy way, the efficient way. So how do you do that? Well, if you hold and select all these, there I've got them all selected. If I right click on that, there's no save as mesh. So that's not going to work. So the way to do that, unselect, is to go over here, right click, new component. Create a new component. It's an empty component. And that's what this is. And then you select and drag these bodies into that component. And that's what this winds up looking like right here. So 4 bodies in there. Then you can right click on the component and save as mesh. And that will give you the menu. All these are highlighted now. And you got this menu, hit OK, and out comes an STL file. So that's where you get it. That's how you do that. So hit cancel. Anyway, after this, we'll move over to a slicer program to get this ready for 3D print. I'm back. We now have open our slicer program. Just a note from, I'm not sure if I mentioned earlier, the 3D printer I will be using for this is a resin 3D printer. Whenever you're doing a really small model, like those miniatures with lots of little detail, you can't hardly beat the resin 3D printers for resolution. Their layer height is really small, and you can use a filament printer for larger prints, but when it comes down to details as small as what we're talking about, you'd have to have a pretty small nozzle and a few other things to make that work. But with the bigger ones, that's fine. You could do that. They do make filaments that are meant for this type of casting, and so you can do that for the bigger projects. So let's move on with this one, new project. Oh, this is Chitubox is what I'm using. There are other other slicers out there, but that there's the build plate. Let's go back to the home position. This is what it looks like when you first open it up. This is where the printing starts on a 3D printer. This on a resin. This is lowered. This is shown upside down. What they do is this lowers down into a vat of resin, and underneath the vat of resin is a clear window they shined UV light up through to cure the resin, and they lower this plate down against that clear window with it's just a thin layer of resin underneath there. They expose that, then they raise it up to the next level, expose that, raise it up to the next level, so on and so forth. So that's how these work. So technically this is upside down from the printer. Now let's load our part. And here we go, all cubes STL3. Boom, there it is. Okay, this is what we drew up in the CAD software in Fusion 360. Now for a filament printer, printing it right on the bed like this is the way to go. Reduces the number of sports and the like. However, for resin printers, this sometimes can cause problems either with a large flat surface area like this can sometimes cause suction and peel the part right off the build plate when you raise it up off the window. Also, the flat areas underneath here, sometimes you wind up with islands between the supports, and that can cause issues as well. It means you have to have lots and lots of supports to make it work. So what they recommend on these resin printers is to rotate this so that it's on edge or on corner. You could do that manually over here, but the easy way to do it is to go over here and auto orient, and there it is. So it's ready for supports. Now, supports, I've said that word several times. What you need supports for is some of these things are just floating out here in space, and you can't print it that way. It's got to have some contact or some way of making contact with the build plate in order for it to be successful. So we had to put supports in there. So let's go. We go over here to supports, and then auto support, and that'll change the menu. And over here, right now I've got the free version of this software. If you get the paid version, you've got more options here as far as these ones marked with the little symbol. But we're just going to use this adaptive support. The original print I tried on this, which you'll see later, didn't work. I used light supports, and I have a couple of videos where where those didn't come out quite good. Some of the inner cubes didn't work, so it turned out what worked better is I went to middle supports, and then I increased the thickness of the contact point where these points contact on there. So let me show you some of that. If you go here, and this right here, I increased this thickness, and on the small pillars, which are little supports that go in between these parts, I increased some of these dimensions as well. And my guess is the reason for that is this resin I'm using is meant for casting, and it's not as quite as structurally sound as some of the others. This is meant to burn away and melt away well. So what was happening is the print was peeling away from the supports as it was being printed, and increasing that contact area seemed to fix that. So let's go ahead and do the support thing. We've got this medium, go along, and then I hit apply, and it does some calculations, and boom, there it is. Okay, and here's the main supports, and then the little ones in between, and where they contact with all that. Looks pretty complicated. It's going to be a real challenge to get those out of there after we 3D print it. And this is a challenging 3D print. It's a challenging one, but that's where we go. Now, one thing I forgot to mention, the printer I'm using is an Elegoo Mars 3 Pro, and the resin I'm using is Siraya Tech Cast Purple. Now, this casting method we're using is very similar to what you use for making jewelry, and it's called the lost wax process, or otherwise known as investment casting. And what you do is when you print this out, in when they make a jewelry, try to say that 3 times. When they're making rings, I can say rings. They'll carve that out of wax, and then they'll pour plaster around that wax. And once the plaster sets up, then they'll melt out the wax and leaves a void in the plaster of which they can pour molten metal in. Well, what this Siraya Tech Cast is basically allowing you to 3D print in something very similar to that wax, so you don't have to carve it. And this is made to burn away cleanly and leave a nice clean void in the plaster when you do that. So that's what we're using here. And there we are. So now that we've got the supports on there, we're happy with that. Then we have to slice it, and that's where it converts this shape into layer by layer by layer, so I can tell the printer how to expose each layer with resin as it's going through here. We go up here to slice, and then you hit slice and slice and save down here. Calculating, and it decided where you want to save it, which I've already got saved somewhere else, and you copy that off onto a thumb drive and take it over to your 3D printer. And then you might want to notice here it's total printing time is 3 hours and 24 minutes and 39 seconds is how long it'll take to do this. One interesting note about resin printers, since it does an entire layer at a time, you could have 4 or 5 of these on the build plate at once, and it will take the same length of time as with just one of them. Now, in a filament printer, that's not the case. If you have 2 of these on the build plate at a time, it'll take twice as long as 1 of these on the build plate. So anyway, there we are. We've sliced it. We saved the file, and the file is a CTB file. It means Chitubox, but that'll load into the 3D printer.
Okay, here we are at the 3D printer. I've got my gloves on. This resin can be a little toxic, so we good wear gloves. And you notice back here in the back, there's an open window to keep the fumes down. So that's where we are now. This is my Elegoo Mars 3 Pro, and this is my washing and curing station, which is an Elegoo Mercury Plus. So before I open this, I'm going to get this ready for washing. This is in the curing configuration right now, so I'm going to get it ready for washing over here. So what I have to do is take this off. This is the plate that rotates the part, and then this is this is ethanol denatured ethanol alcohol, and it's denatured, but they put a little bit of stuff in there to make it poisonous. I think it's methanol. So at Lowe's, it's called Fuel. As you can see over here, it's denatured alcohol, but at Lowe's they call it Fuel. So anyway, now that's got a magnetic stirrer in the bottom and a basket, so that's ready for washing. So first off, let's see how this print came out. Okay. Ooh, that wasn't very tight. Hope it's okay. Let it drip a little bit, and I'd say that looks really good. I like it. It came out good. Okay, so I'll put it in here. Now, before I start that, I'm going to turn this off. To show you a little bit on this printer, this here's a little heater I put in here that at room temperature, 70 to 72 degrees Fahrenheit, the resin's a little bit too cold. It doesn't always print very well. So this raises it up to 30 degrees C, which what's that, 80 or 82 degrees F, and this is aftermarket, and that's what this is in here for. So I highly recommend using that. This came with the printer. It's a filter. It filters the air to help take care of some of the fumes. So that's that set up. Let's put this back on here. The resin is UV sensitive. That's what cures it. So you want to keep this on here as much as possible to do that. Okay, that's that printer. And now let's look at the washing station. We'll turn it on. It's in the curing mode, so we switch it to wash. Whoops, there. And then go up to 5 minutes. Put this lid on. Keep the fumes down a little bit and go. And for half the wash time, it spins one way, and in half it spins the other. Okay, now the wash cycle is done. So take the lid off. What that wash cycle does is removes any of the uncured resin from the outside, the stuff that's still just purely liquid. Set that down here. Okay, now we need to remove that from the plate for the cure. Let's put the cure part back together first. Okay. Now this spatula or putty knife, it's sharpened or beveled on one side but not on the other, which makes it where you can lay the unbeveled side flat against this plate, and then this is how I remove the parts without scratching the plate. One sport came off, but that'll be fine. But there we are. Now set that on the cure thing. Let that dry out. There. Now we switch this over to the cure mode, and 5 minutes. There we go. You have to have this on here or it won't work. And there you go. That runs for 5 minutes. Okay, it's done curing, but while I was curing, I noticed a problem. The inside, the inner cubes, the inner two cubes are not right. They've failed somehow. So I might try printing this again. try to get them to come out right. I don't know what happened to them there, but I don't think I'm going to cast this one. I'm going to try it again and see if I get a better print.
Okay, at this point, I thought the failure may have been because the screws that were the screw on the build plate, when I took it off, I noticed it wasn't very tight. So at this point in time, I decided to try printing it again. However, as I mentioned earlier, it turned out it wasn't that screw. It was the fact I used light supports, not enough contact area. So we'll try it one more time, and it'll fail again, and I'll come back to you.
Okay, here we go. We're back to see if this print worked better. So let's see. I'm going to turn this off. Pull the USB out. And I can tell already it's not much better. It looks just about the same as the last one. The inside two cubes failed. So I'm going to have to try a different style. I think see the hole in the middle? I think the supports need to be a bigger contact area again. So what I might do is go to medium supports instead of light and give it a try. So I'm going to go ahead and wash and clean this and maybe use it for something. So anyway, well, we're going to try it again here. Third try on this one. See what happens. I changed the supports to be medium supports, and then I increased the contact area and a few things like that. So let's see how it goes. Forgot something. I forgot to put on my gloves. Okay, let's power off. Get this out of the way. And let's see here. It's good. See there, the inside cube is there and it's solid. It's hard to tell in this lighting, but to me it looks like all four cubes are good in there. It's hard to tell in the lighting, but I think we got it. Yay!
Okay, I'm not going to make you sit through another washing cycle on this, but the curing cycle does have some interesting information to include, so here we go on that.
Off without scratching the plate. So I'm going to set that here, let it dry, and normally we would take this and put it on here right now, but there's an extra thing we need to do. When we go to cast this, this part here is a sprue or cup or whatever you want to call it, and it serves the purpose of, it leaves a little cup in the top of the plaster to pour the molten metal in there. I drilled a hole through the middle of it because I think that there's a good chance that this will melt faster than this will. I did this on my filament 3D printer. This is PETG, so this might melt first, so I want to have a vent hole for that to drain through or burn out or whatever. So this is what we have to do. We have this part, and then this gets glued on there, and then this can gets glued on top of that, like so. Alright, so that's what we're going to do. Now the way we glue this on here is interesting. Let me set this here. I dipped the bottom of this just barely into the resin, like so, just barely into the resin, and then set it on here where I want it. making sure it's right over that hole. Then I put that in here. Back on. Put this on. Okay. Then we switch this to the cure mode. 5 minutes. 5 minutes and go. So there we go. We're gonna let that run for 5 minutes. Okay, done curing. Those lights in there are all UV diodes, and they won't come on if this is off of there, so that protects you. So anyway, there's the part, and as we said, the next step is to put this can on here like this. We find to smooth this side and make sure it's up, and the other side, what I'm gonna do is go over here and use a hot glue gun and seal this down to that. Nice and centered all the way around. I'm not going to videotape that part, but yeah, get just a regular old hot glue gun, seal it all the way around. All right. Okay, last thing I showed you, I was going to glue this on, and I used hot glue to do that. You can see it on there. It's all done. Next step is we take some investment powder, which is like somewhat like plaster, and fill this up with that, and we'll show you that in a little bit. Once that's set up, then we put it inside the kiln and burn out all that plastic, and then help center or set up the plaster a little bit better. And then once it's preheated, what we'll do then is we'll move over here. That burnout process is 14 hours, and we'll get into that in a little bit. Then we'll take it out of there. We'll put it on this vacuum table. This pulls the vacuum, and I get about 9 psi of vacuum. At that point in time, there'll be a cup in the plaster here where this plastic is. Then we'll take the molten aluminum and pour it into there while it's pulling a vacuum, and that will be the tricky part, but we'll get into that in a little bit. Right now, what we're going to do is pour the plaster. So set this over here. Now the powder I use is Prestige Optima Investment Powder, and again, it's plaster with a little bit of extra stuff in there. I'm not sure what. I have a scale. This is what we're going to mix it in. So let's get the investment powder first. I use a half a kilogram of this, so 500 grams. So on 0. $500. So there's 500 grams of that. And next I'll get 200 grams of water. This. So let's go to tare. And I'll get some water here. And 200 grams is what I'm looking for. Okay, there we go. Now we have 8 minutes to process this. According to the instructions that came with it, we're supposed to stir it for 4 minutes, which is probably more than it really needs, but you stir it up until it gets really nice and mixed, scraping the edges, scraping the bottom. Okay, I think that is mixed good enough. That's probably not 4 minutes, but it's close enough for what we're going to do. Then we put it in the vacuum chamber back here. Okay, the needle's going up on the vacuum gauge. Here, it's going up. You look in there, you'll see it starting to bubble a little bit. The first bubbling will be air coming out of the plaster. That's what you see now. All of a sudden it gets a lot more. That's boiling water. This pump pulls it up back into the boils water, and that helps pull the air out of the plaster as well. So it's supposed to do that for a minute. Okay, that's not quite a minute, but I think that's good enough because we're going to do some more. So we turn that off, slowly let some air in there so it doesn't splatter plaster everywhere. Then we pour that into here. There was a lump went in there. I think that'll be okay. Something didn't get stirred quite well, but it'll be okay. Then you put it back in here and vacuum it again for 2 minutes. Gauge is going up. Okay, I'd say that's probably long enough. So I'll turn this off. Get out of here. Okay, I don't see any plaster leaking. That's a good sign. All right, so this is going to take a little while to set up. After about 8 minutes, since we started mixing it, it'll start getting thicker. So let me lower this down and we'll talk about what we're going to do next. What we have here is a pottery kiln. Get this off from it. And this is programmed. I'll get on my schedule here so I can tell you what it does. Once that's set up, then what we do is take this lid off. And down inside here, we have things in this order. I have a metal tray down here that is like the bottom of some cooking pan that I trimmed the edges of it off. It's stainless steel, and I put it in the bottom of the kiln. Then I put these ceramic spacers on here. Then I set this on top of that and it's got a hole in it. And then this can that we just did goes on top of that. That's what's going to be inside the kiln. Okay. So let me put all that back in there. Okay, and then very important parts right here, 1/4-inch bolts. I put them here so that the lid has a 1/4-inch gap to let the air out, let the smoke out as we go through here. Now this is the sequence. We ramp the temperature up at 100 degrees C for an hour until it gets to 100 degrees C, and 100 degrees is where it boils water. So you leave it at 100 degrees C for 3 hours, and that gets all the water out of the plaster. If you heated it up too much, too quickly, that water would turn to steam and explode the plaster. So 3 hours of soak at 100 C. Then you ramp it up to 450 C, which burns and melts out all the plaster. You hold it at 450 C for 2 hours. When that's done, you ramp it up to 780 C, which kind of centers the plaster and the other stuff in there so it sticks together and it's more rigid and more sturdy. You hold it at that 780 for 4 hours, and then you cool it down to whatever temperature you want to preheat the mold at. Now what I usually do is I have it preheated to 500 degrees C, so when I take it out of this kiln and get ready to pour the molten aluminum into it, that can and plaster is 500 degrees C. So that's the sequence here. Now you got to time this, so I'm going to start this tell it to start at 7 p.m. tonight, so that by 10 a.m. tomorrow is about the time it'll be cooled down to where I can melt my aluminum and pour it in the mold. So that's how all that works. Okay, a couple of things I forgot to mention. When you go to set up this kiln, you need to make sure that there's nothing flammable anywhere around it, and same thing goes for this melting furnace over here. You double check to make sure nothing around it's flammable. I have a vent hood up here, up there, that I will turn on to take out any smoke and fumes that comes out of there. Also, I run this kiln on a different breaker than I run this melting furnace, just in case. So when I turn both on, I'm hoping it might. I'm not sure if it'll blow a breaker on one, but I like to be doubly sure. Okay, here we are the next day. This has gone through its 14-hour plus process and burned out all the plastic. A lot of residue left this time. This is hot, I shouldn't touch it. So next what we're going to do is we're going to put aluminum in here, melt it, and then do the trick where we take the can out of here, set it on here, make sure we've got a vacuum seal, take the aluminum out of here and pour it into there. And so we're going to get to that. Right now I'm going to test to make sure the vacuum's working. It's always best to troubleshoot that now. So turn on the pump. Here's the can with the bottom still in it. So I put it on there. Yep, I can hear it straining, so it's got a good seal. Alright. There we go. And the aluminum I'm using are these ingots that I cast out of melted pop cans, aluminum cans. So it took a lot of cans to make all the ingots I have, but that's what we've got. So I'm going to turn this on. It's currently set for 900 degrees, which is what I did last time. It worked okay. So I will slip this down in here. Now this will take about 20 or 30 minutes to melt that, and then the excitement gets really big. Mentioned earlier, this is like hours and hours of waiting, interspersed with a few moments of panic while you're doing all this stuff all at once. So it'll be exciting when we do this. Okay, we're getting closer here. The aluminum's not melted yet, but just a reminder, this mold is preheated to 500C. This furnace is set to 900C, although it's measured outside the crucible, so inside the crucible it's not quite that warm. Right now it's up to 857, so we're getting close. The aluminum hasn't quite melted yet, but it won't be too long. I forgot to mention that I put a little bit of this light salt in there for flux. This is half sodium chloride and half potassium chloride, and it helps separate the clean metal from the oxides and all that stuff. So I'm preheating this little ingot mold just to make sure that there's no moisture in there. In case I have more aluminum than I can use, I can pour it in there, but I won't need it, but I do that anyway. Gloves are very important on this because everything is very, very hot. Okay, this hit 900 on the measurement. The aluminum is all melted in there, so I'm going to put my gloves on. Add a little bit more salt. Stir that in. Skim a little of the dross off the top. Not much, it's pretty clean aluminum. Okay. Let that heat for a while. But here comes, this is the exciting part. We'll let that soak a little bit more. Things are glowing nice and red down in there, so I think we're good to go. So first thing I'm going to do is turn on the vacuum pump. Hopefully you can hear me over that. Turn this off. Now when I lift this, I'm going to lift it away from me so the heat goes away from it. I can hear that screening, so it's pulling a vacuum. Oops, let me do this. Very hot. That off. Let me put this lid back on. Now the aluminum stays molten for a while. I have a feeling that by now all the aluminum that's going to suck down in it has already done so. So I could probably turn off the vacuum pump, but I'll leave it on for now. Okay, and that vacuum. Once this aluminum has solidified, I'm going to pick the whole thing up and quench it in water over here. This rubber material here, I got that on Amazon. It's a high temperature silicon. Its rated temperature is a lot lower than what I'm exposing it to, but I find out that it holds up to a lot higher temperature than its specification says. As you notice, this is theoretically at 500 degrees when I set it on here, and it did not hurt that rubber sheet. Okay, I think we're there. So let me move this back so you can see the exciting part. Bucket of water, or tub of water, I should say. Grab this with the tongs, and again, trusty tongs here. And when we get done, nothing left in the can. The steam boiled, blasted away enough of the plaster that the metal part fell out, makes it convenient. Now there's not much left of this can, so once it cools down, I'm going to throw it away. There's no sense in trying to reuse it because this is just paper thin now. So I set it here to cool. Take off my gloves. Water is still cool. Okay, here's the cut part. This is the cut part, and the shrinkage when it cooled pulled the good part off of it, so it's down in here. Let me find it. And there we go. Isn't that great? I love it. Now it's still got a lot of plaster in there. I could throw this in an ultrasonic cleaner, but I have a little textile blaster over here that I'm going to use to blast all that out. Here's that textile blaster. It's like a miniature pressure washer that's made for blasting stains out of clothes, and just using straight water. It really blasts. Now I've used one of those as a demo. I cut a carrot in half with it. So you got to be careful not to get your fingers. It does hurt. I've done it. So what I do is I hold on to the supports with some needle nose pliers to protect my fingers, and then I blast. Noisy. But there we go. most of the plaster knocked out of there. There may be some more come out when we knock out all the supports. So now the tedious part is to take this upstairs or wherever and gently nip out all those little supports. Okay, I'll be back after I do that. Okay, an update on my casting project. This is the one I showed you earlier, 2 nested cubes. I 3D printed it in plastic and then cast that into metal. Now, the problem with this was it was actually 5 nested cubes, but the inner 3 didn't work. So I thickened up the sides, and that's what we have here. We have 4 nested cubes, all of them turning independently, and it worked this time. So I'm really tickled. It took me a long time to free up that center cube, get all the supports off from it, but you can tell there's a 4th cube down there in the middle, and they all turn separately. They're all free to move independently, but they won't come apart. Anyway, lots of fun.